Alrighty, so we are now talking about these special triangles. So you have two special triangles that you'll have to kind of acquaint yourself with. And remember, you don't have to memorize these. Don't memorize, but understand. Understand how to use. These special triangles are listed on your data sheet, okay, or your formula sheet. And again, I'm never going to ask you to memorize them, but I will ask you to know how to use them. So for angles 30, 45, and 60, you can determine the exact values of trigonometric ratios, okay? And this is whenever you have, this should say for right angles. So they kind of get special names. One is the 45, 45, 90 degree triangle, okay? And why is it special? So drawing the diagonal of a square with a side length of 1. So here we have square where we have side lengths, and then we are drawing the diagonal between those two things. So this is your first special triangle. So the first thing is, let's just determine the hypotenuse here. So remember, this is from Math 10, so Math 10 review, I guess. There's a few things you want to remember about Math 10's values, okay? So in Math 10, you learn that a right triangle has a 90-degree angle, okay? And as soon as you're dealing with right triangles, you can do a few things. You can use Pythagoras, so a squared plus b squared equals c squared, where c has to be your hypotenuse. Hypotenuse. I always spell that wrong. Pretty bad for a math teacher, but whatever. And then you also have your trig ratios that you can use. So remember, a trig ratio, you're going to remember SOHCAHTOA. So sine angle equals opposite over hypotenuse. Cos angle equals adjacent over hypotenuse. And tan angle equals opposite over adjacent. If that is all gibberish to you, you need to come in right away and ask some questions, or you need to watch the video that I had Math 10C review listed. So a right angle will always look something like this. You have your 90 degrees here. So that's a 90-degree angle. The hypotenuse is always the longest line or arm in your triangle, and it's always opposite of your 90-degree angle. And then this could either be A or B. It doesn't matter. This could be A or B. Okay, so that was a really quick little review of Math 10C trig. But if you need a review more, come and ask. So here we're dealing with a right triangle. It wants us to find the hypotenuse, which is C, because again, your hypotenuse is always found opposite of your 90-degree angle. So here, the biggest important thing is that your hypotenuse is C in Pythagoras. So a squared plus b squared equals c squared. A and B are interchangeable. As long as you make one arm A and the other arm B, you're good to go. So I'm going to make this arm A and this arm B, as long as your hypotenuse is C. So this will be 1 squared plus 1 squared equals c squared. 1 squared is 1. So this will be 1 plus 1 is c squared. 1 plus 1 is 2. And from here, I'm going to square root. So I end up getting c equaling the square root of 2. And this is your special triangle. Again, this will be on your data sheet, but this is very important. So you have, anytime you have, oh, that's not a right triangle. Anytime you have a right triangle, so 90 degrees, and it has a 45-degree angle, that means the other angle will be 45. And then you immediately know you have 1, 1, and root 2. So this is your 45, 45, 90 angle. Something last to mention for Math 10C review, and this is a huge one, is all triangle angles add to, they will all add to 180 degrees. Okay, so don't ever forget that. So if you have one angle in a triangle, or if you have two angles in a triangle, you can always solve for the last one. Okay, so there is your introduction to our first special triangle, the 45, 45, 90 angle, or triangle. So let's go to B, and given the following diagram, find the trigonomic ratios. So due to annoying formatting, I'm going to just quickly draw out this other triangle here. So again, 45, 45, 1, 1, root 2. Okay. So here it says, find the trig ratios. So this is a little bit of a throwback to Math 10C. So again, if you don't really remember what trig ratios, please come ask or watch a video. Trig ratios, okay, they're not asking for the angle, they're asking for the trig ratios of the angle. This is your sine, cos, and tan. That's what we're talking about here. So remember SOHCAHTOA, where sine is SO, which is sine angle equals opposite over hypotenuse. Now recognize this is why it's a special triangle. Regardless of if you use this 45 as your angle that you're talking about, or this 45 of the angle you're talking about, the ratios will still be the same. So it doesn't matter which 45-degree angle you use. The ratios will be the same. Okay, so at this point here, let's plug in our 45 in here and check what the opposite is. So sine 45 degrees, and you know what? I'm going to highlight here. I'm going to say that we're going to use this. Again, it doesn't matter, but it's good to reference one at least. So for this 45 degree, what's the opposite side length? Well, if you look here, the opposite side length is the side length that is opposite to that angle. So right here. So this is opposite. Meaning that this has to be the hypotenuse, and lots of people mix this up because sometimes they might think when we get to adjacent that this is the adjacent, but a hypotenuse can only be hypotenuse. Okay, so my opposite is 1, so this will be 1 over my hypotenuse, which is root 2. So there we go. You're done. You pretty much have stated this. You can now say the sine ratio for 45 degrees in this triangle is 1 over root 2. Stating this in math terms is literally just putting it as this. Sine 45 degrees equals 1 over root 2. Okay? Now, something I suggest is knowing how to rationalize. So recall rationalizing. Again, something you learned in grade 10. So if you don't remember what rationalizing is, I have a video linked to review that. But essentially, rationalizing means not having square roots in denominator. Okay, so how do I get rid of a square root in a denominator? Well, what you're going to do is you're going to multiply the top and the bottom by root 2. And that's as simple as that, because square root 2 times square root 2 cancels each other out, and you're left with root 2 over root 2 times root 2 equals 2. Something to note, this you do not have to do at the moment. If you left it as this, I would mark it correctly, unless otherwise told that you have to show rationalization. That will probably be later on in the course. But for now, just focus on knowing how to find the ratios here. Okay, so let's find cos. So this was sine. Let's find cos. So ka toa. So cos angle equals adjacent over hypotenuse. Now in this case, what's my adjacent side length? Well here, adjacent means beside. That's what adjacent means, beside. So you're asking yourself, what leg is beside 45? You might say, well, there's two, but remember, hypotenuse can only be hypotenuse. So we have to use this one as my adjacent. So cos 45 will be 1 over, and then my hypotenuse is root 2. And there you go. There is your cos angle for 45, cos 45. And lastly, we are now on to tan. That's our last trig ratio. So remember, tan is TOA. So tan angle equals opposite over adjacent. You've already noted that the opposite is 1, adjacent is 1. So if we plug in tan 45 here, my opposite is 1 over 1. So it equals 1. Tan 45 equals 1. And if you plug that into your calculator, that's exactly what you'll get. So let's see here. So make sure you are in degree mode if you're going to try this out on your own. So right now, where are we? So mode, I'm in degree mode here in my calculator. So I'm going to write tan and then press 45. So it gives me 1. So see that? Tan 45 equals 1. Let's see if I take the inverse of tan of 1. Well, then that pops out my angle, 45. So some things to note there. So that was our exploration of our special right triangle, 45, 45, 90. Let's jump into our new angle, or our other special triangle, which is the 30, 60, 90 angle. Okay, so here we can see a special triangle of 30, 60, 90. So 30, 60, 90. And these are the side lengths that you're going to be dealing with. This helps us find trig ratios for it. So in this case, given the following diagram, find the trigonomic ratio for 60 degrees. Well, at this point, we are focusing on our 60 degrees here. So I'm going to redraw this just so I don't muck up our nice little drawing here. So you got 60, 30, 1, root 3, and 2. So something to note is no matter if you're finding trig ratios based on your 30 or your 60, this is always your hypotenuse, right? Always opposite, and then of your 90. And then depending on if you're focusing on 30 or 60, then your opposite and adjacent change. So my 60 here, the opposite is here. Then we have my adjacent, and then you have the hypotenuse. Okay, so now that we have our triangle drawn here, we can start using our trig ratios, which is sine, so, cos, ka, toa, tan. So let's focus on sine first. So sine angle equals opposite over hypotenuse. Okay. Now remember, what was our opposite here? Well, first, let's plug in what angle we're focusing on. In this case, it's 60 degrees. My opposite angle to 60 is root 3. So this will be root 3 over, and what was my hypotenuse? 2. And there you've actually found the trig ratio for sine 60. So what does this mean exactly? Well, if we take out my calculator and I press sine 60, you get 0.866025. Let's plug in root 3 and divide that by 2. And you can see you get the same values. This is why special triangles are useful, because this here is an exact value. And that's a very powerful thing in mathematics and engineering and all sorts of fields, knowing an exact value. Whereas this is an estimate. This is a decimal given. Okay. Let's figure out our cos. So cos angle equals adjacent over hypotenuse. And again, we're dealing with cos 60. And what's our adjacent here? Well, we notice that the adjacent is 1 over our hypotenuse of 2. So cos 60 equals 1 over 2. And again, if we throw that into our calculator, we should get cos 60 to equal 0.5, which it is. 0.5 is 1 over 2. So that works. And then lastly here, we will do tan. So tan angle, that's TOA. So that's opposite over adjacent. So at this point, we have tan 60. Our opposite side length is root 3 over our adjacent side length, which is 1. So we get tan 60 to equal root 3. And again, if you plug in tan 60 into your calculator, it'll give you a decimal, but that decimal, its exact value is root 3. So tan 60 and then square root 3. So you can see root 3 is our exact value. That's the special thing about these special triangles. They give us exact values. Okay, so let's quickly do D. I won't kind of mull it into the ground as much as I did here, but quickly draw out our triangle. And I would suggest maybe pausing the video at this point and trying to do D on your own. See how it goes. Remember, this has to be your hypotenuse, but now we're focusing on from the perspective of 30. So this is opposite, this is adjacent. So tan angle equals opposite over adjacent. TOA. Tan 30 here, the opposite side length is 1, and the adjacent side length is root 3. So there you go, there's your ratio for that one. Then we have sine angle, which is opposite over hypotenuse. So sine 30, what's the opposite side length? It's 1 over hypotenuse, which is 2. So there is sine 30. And then lastly, cos 30. Well, I guess we should mention what cos is first. So we should know now that cos angle equals adjacent ka over hypotenuse. So my adjacent to 30 is root 3 over hypotenuse, which is 2. So there is cos 30, root 3 over 2. So there are all your ratios. So let's finish this off with example 6. So here we got a few things going on. So Sarah is learning to play the piano. Her teacher uses a metronome to help her keep the time. The pendulum arm of the metronome is 10 centimeters long. Okay. For one particular tempo, the setting results in the arm moving back and forth from a start position of 45 to 135. What horizontal distance does the tip of the arm move in one beat? Give an exact value. Okay, so what horizontal distance? So if you've never heard of a metronome, they're little gadgets that keep tempo. So they just go back and forth and they click. They go click, 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 click. Okay, and they give a beat every time. One beat is from here to here. That's the length of a beat. So we essentially need to figure out what A is and multiply it by 2, because both of those things represent A. Now, they've been kind of nice to us in terms of giving us certain values here. Let me just think about this one. For the setting results in the arm moving back and forth from a start position of 45 degrees to 135 degrees. Now, a little confusing on why they gave us these values. Just let me think here. So this one should actually say, sorry about that, should say 60 and 120. I must have been thinking about the different triangle here. So anyways, at this point, they've given us a diagram to work with. So our length here is 10 centimeters, okay, and then we can go from there. Now, what do we notice? As soon as we see 60 and a angle there, we should be kind of pumped because that means this automatically would be 30, because this forms a right special triangle. Okay, so here we have a 30, 60, 90 triangle. And the coolest part about special triangles is recall that on your data sheet, you will have the special triangle listed as this. So you have your special triangle that would be above there. So you have 60, I guess I should make this thing a little bigger here. 60, 30, and 90. And then above, we got root 3, 1, and 2. So root 3 is opposite of 60, 1, and then 2. Okay, so at this point, recognize, if I decide to multiply one of these lengths by a number, all of those values get multiplied by that same number. It's because of similar triangles. So if I decide to make a right triangle that looks like this, and it's in the same orientation, so 60, 30, and 90, let's say that I make this bottom length now 4. Well, that means in order to get there, I had to multiply this number by 4. So that means this side length will be this times 4 as well. So this would become 4 root 3. And then I had to multiply this number to get to this length. So this would be times 4 here. So that would become 8. So similar triangles allows us, as long as we have the proper angles, you can pretty much always use these ratios, which is really cool. So even though it only gave us one length, the fact that it's a special triangle allows us to be like, oh, well, guess what? I can figure out each length here. So here, let's maybe draw out one more special triangle. Let's draw the regular one out here. So we got 90, 60, 30, and the opposite leg of 30 was 1. So this is 1, root 3, and 2. Now look what our hypotenuse has turned into. It's turned into 10 centimeters. So we have the same special triangle due to the angles, but this has become 10 centimeters. Now, how do I get from 2 to 10? What do I multiply by? Well, I multiply by 5. So that means this side length here will be found by multiplying this by 5. So this will become 5 times root 3. And then here, our bottom value will be 1 times 5. So our bottom leg is now 5 centimeters as well. So now we have some awesome values to work with. And we've essentially almost answered the question. So what horizontal distance does the tip of the arm move in 1 beat? Well, you can see here that the horizontal distance, so A, is found, and that's equal to A here, which is equal to 5 centimeters. So that's 5 centimeters, this is 5 root 3. So our answer is 5 centimeters. Okay. And, or sorry, yeah, 5 centimeters. And that was has now allowed us to find the exact value, 5 centimeters, by knowing our similar triangles and knowing our special triangles. We were able to answer it pretty easily. So always look for the numbers 30, 60, or 45 when you're dealing with a right triangle, because as soon as that pops up, you're kind of on your way. You're set up because you got tons of this stuff to work with. So if you could go try out these questions here, practice them in your textbook and see if they make sense, okay? Other than that, if you have any questions, please come ask and make sure you practice a few practice problems. Have a great day.